Okay, so we've got another example to vertical motion under gravity. The ball is projected vertically upwards from a point X, which is 7 meters above the ground with speed 21 meters per second. We're going to find the greatest height above the ground reached by the ball, the time, and then also the time of flight of the ball. Okay, so think about what's going on here. We've got point X, sort of here. We've got this ball, it's going to go up, and it's going to come back down again. So it starts with this speed of 21 meters per second. So that's going to be u. The acceleration is going to be downwards because it's gravity. So the acceleration, because it's going downwards, I'm going to call it minus 9.8 meters per second squared. So we want to start with the greatest height of the ball above the ground. So at the top, it's basically stopped there. So it goes up, then at this point it's stopped. So this is when v is equal to 0 meters per second. The other thing here is that this distance is 7 meters. Let's notice that as well. Okay, so we're trying to find a height. So we're talking about s is what we're trying to work out. And we've got the three things that we just put on our diagram, which is u is 21, v is 0, and the acceleration is minus 9.8 meters per second squared. So what we'll find here is this distance. So at the end, because we want the height above the ground, we'll need to add on 7 as well. Okay, so the equation that connects those four things is v squared equals u squared add 2as. I can just substitute everything in. So I've got 0 is 21 squared plus 2 lots of minus 9.8 times s. So in other words, 19.6s is equal to 441, and so therefore s is 441 divided by 19.6, which is 22.5 meters. So as I mentioned a moment ago, that's what this distance is, but the height above the ground will include the 7 as well. So height above ground is just going to be 22.5 plus the 7, so 29.5 meters. Okay, and then part B, the time of flight of the ball. So we're trying to find t. We've still got u as being 21 meters per second. We've still got the acceleration being minus 9.8 meters per second squared. The displacement from here to the ground is going to be minus 7 because it's gone downwards. So s is minus 7 meters. And we just want an equation that connects the four of those things, which is s equals ut add a half at squared. Then we can substitute everything in. So minus 7 is equal to 21t minus 4.9t squared, or 4.9t squared, take 21t, take 7 equals 0. So it's a quadratic equation, and we can solve that in a number of ways. Perhaps easiest way, just use the quadratic solver on your calculator. You'll get two solutions. So t is 4.60 or minus 0.311 seconds. So as t is greater than 0, t must be equal to 4.60 seconds.